So in this video, I wanted to highlight some functionality with inside of DesignX that we use on occasion. That's one of my favorite little features of modeling with surfaces on this part right here that we were given. And this video will be more of like a kind of a tutorial, not like a demo, but a little longer form tutorial on how to go about doing something like this. It may not be the fastest way to do this project, but it's kind of a neat way to do it. So that's why I wanted to kind of walk through these steps. So we'll go ahead and get started. So yeah, you see this, we got two flanges on each side. Those are pretty easy to model. And then we have this little port sensor area. And then you have this flow, it's like a lofted shape, which you can do it with a loft, but sometimes you're going to fight trying to get the loft curves correct. So a lot of times what I'll do is I'll just do a Control C, Control V, and paste as a new piece here. Sometimes I'll change the color and set it for another different color there, hide the other one. And this is something that I've had to do in certain projects in the past that is really handy. Being able to just modify the mesh and using mesh modeling tools alongside of CAD modeling tools side by side. So that's what we're going to do is show the boundary fit surfacing and how sometimes I'll go through. And some of these steps, again, you don't have to do every single one the way I do it here, but it's just a general idea of how I would go about doing it. So I'm going to go ahead, and again, you don't have to create a region. You could just create a plane, but I tend to like to use regions, so it's almost like a saved selection. And so we'll just create a couple of regions there and create planes because I like using the cut with the plane here. And we can offset it to get rid of the flange weld there. So we're just kind of offsetting far enough to get rid of the flange weld. Hit OK. The same thing down here. Do like an offset plane about the same distance. So I can cut those just using regular selection modes, or you can come over to the polygons tool and come over to split or trim. So split, you can say split by entity, which is nice. So I can say I want to split using that entity, hit next. And whatever is selected is what you're going to keep here. So you can hit OK, and you see here that it cuts it for you. And the same thing goes if we just select that same mesh by entity, next. By default, it should try to keep the bigger side. There are times where it just doesn't do it. It just will flip the selection for whatever reason, but just to let you know that happens. And then if we want to remove this port, we'll get out of that tool. And there's some cool tools here. This custom region may work. Let's go ahead and try it. Sometimes if you have a tunnel that goes down into the mesh, it may not select, but it looks like it did. So look at that. It went ahead and got all the way down inside and grabbed that piece too, which is perfectly fine for what we want to do. Go ahead and get rid of that. So that's a way that you can do that, a custom region tool. I like that because it's going to select everything within the boundary that you create. Say everything inside of here, go ahead and select. So there we go. And then we can come over to fill holes. And it's going to say, yeah, there's some issues with this mesh. And we'll try tangent first. Looks good to me. And then same thing with this, we'll try tangent. So sometimes if it has a little dip in there that you don't want, see, it does look like it has a little bit of a dip. I can undo. You can come over and do bridges. So if you say you want to do a bridge across and break this up, this is another way you could go about doing it. Like that. Or one thing that I found that works pretty well is you can come over and say, I want to do a fill partial, and just kind of maintain that curvature all the way around. Sometimes when you do it this way, it kind of creates a little more tension on that edge and causes it to not dip as much. That's why I'm doing it this way. You can fill holes a whole variety of different ways, and it's really all about just looking at the results and trying it based on your experience. Um, because the idea here is just to create nice flow and smooth. So if there are some extra wrinkles in there, you can come back with the smart brush, hold Alt to change the size, and you can smooth these guys out. Smooth the heck out of it. And same thing here, you can smooth, relax. You can even refill and reselect and refill and stuff like that to try to get a better smooth. The idea here with this is I want to create one nice continuous flow without defects in it as well, because we're going to fit surfaces to this. So I'll come around and I'll remove some of these guys, these little flakes here and there. And then you can do a global smooth too. So if you want to say, let's just try it on max, see what happens. Not too bad. Smoothing the heck out of it. If you see any witness lines, any little divots or whatever, again, you can use that, or you can come over to defeature too. Defeature is nice where you can select and it will do the whole fill all in one. And again, Smart Brush is awesome to come back and smooth any transitions. But I think that's pretty good. So we just created this shape. Switch back to rectangle. That helps with our modeling selection tools if you switch back to the rectangle. And then we'll come over to 3D sketching. 3D mesh sketch. 3D mesh sketch, you can say, I want to create curves from the boundaries. Like so. And if they're a little wrinkly there, you can do another trim. That's a good point. Like I went ahead and trimmed it and then, here, let's just do this real quick. Discard. You see how I did the smooth and it made it a little bit wrinkly on the end? So there's a couple things you can do. We could go ahead and just retrim it nice and flat again. Because I'm a little bit, like, I just want it to be nice and clean. So let's just do that. So basically what we're saying here is I could have done this a different way where I smoothed it first and then, here, let's do this real quick. Before we do that, I'm just going to do a healing wizard on it. And it has a couple little things, so we'll fix that. So we'll just go ahead and just offset just like a little bit more. Because after I did the smoothing and cleanup, we'll just go ahead and offset that. About the same, yeah. Then we'll come over to polygons. Now, you can do a trim, but trimming works different where you use like 3D curves. If I drew a 3D curve, in this instance, I'm going to say, let's trim based on that plane. And we'll do this again. So now my boundaries are smooth. Now you'll see why, because when I come over here and I go into 3D Mesh Sketch and I say I want to convert the boundary, it's going to have a nice smooth boundary versus what I had before because it was chattery because I smoothed it, right? That's basically the concept of why I did that. So I'm going to create a curve around that boundary. as well. And then just do splines. And I'm just doing this fast on this call, so maybe not be, they won't be perfect, but just see how we're drawing those flow lines along that shape here. And you can move these later. You can drag them, move them around. You can drag just individual points and smooth it. Sometimes it's even easier just to redraw it if you messed it up because there's so fast to draw these. So I right click to end those curves, by the way. Sometimes I forget to tell people the shortcuts and stuff because you do after a while you get used to using them and you forget to even tell customers how to do that. But I'm basically just considering like I want enough patches to capture the overall shape without going crazy and doing too many. Probably could get away with a few less, but if I'm doing them, I usually just go a little extra there. So you see that I drew those shapes, not perfect, like you can always redraw them, move them around. Another tool that's nice is you can create curves by sections. So you can just draw on the screen. You see that it creates a section curve through. So this is handy for this type of work where you say, I want to create ribs on these. Like that. Looks good to me. And then I'm going to select all. And I'm going to say intersect them all right there. And I'll put intersections at each of them. Okay. So now we created this little curve network. Always save. And then come over to menu, add-ins, boundary fit. And if you just click on the 3D network, 3D sketch network, and hit next, you'll see that as long as they're four-sided, it'll automatically figure out how to fill them all. And you can add the resolutions here, and you can adjust the smoothness, all of that. And this is editable, actually. It will remember the settings here once it finishes. So I thought about it for a second. I'm like, it is editable, so let's open this again, hit next. Maybe smooth it a little more. Like it's pretty smooth, but and then I can reduce these down to like 6x6. Maybe I don't need that kind of resolution. Just reduce the control points. And again, you can play games with how close you need to follow this. Many times these types of parts are casting parts that have deviation and error in them. So speaking of that, we can come and turn this on and crank it up and just see where we're not following. And again, areas can have that somebody could have took a grinder to it or wire wheel or something, and you have to make the decision how close I want to follow it. But just in general, trying to smooth it out is good because with the surfacing modeling, you don't want wrinkly surfaces. You need nice clean surfaces um, to take it from there. So now I'm going to pause on this shape and we'll go load up this guy and you see how far back these are and you see the flanges. So we can go ahead and model the flanges. So we'll turn these guys on and you see that we have those planes there. I can create new planes. I could model it based on this side if I want to. So again, I kind of always tend to use my regions. And we actually did the regions on the other one, but if you wanted to create them on this piece as well, insert. Just because I've noticed over the years of modeling, right? If I don't save the selection, sometimes I really want to come back to it. So I use these regions as save selections. And sometimes I will create, even if I don't think I need this right now, I'll create it the moment just because I'm at it, because I think I might need it later. So one little thing, you don't have to do it this way, but you'll see here that I clicked on that region. Um, I don't have to create a plane for it. I can come right over since it's a planar region. And I can come over and create my mesh sketch directly on that if I want to. And then we'll just hide our surfaces. Come in, and just for the sake of time, I am not going to sit here and dimension every circle. I don't think people want to watch me do that and dimension every little thing. But if I'm modeling this to go make thousands of them, yes, I would. I would come back and dimension things out properly, right? But just again, for the sake of time, you guys don't want to see that. You guys get how to do that if you've modeled in CAD before. But this is generally how I approach this stuff here. Is I kind of rough it in and then come back and add my dimensions and constraints and relations. Just kind of come around and create all of it. And you notice I'm not going to do the inside yet. I'm just modeling the exterior of the flange. We'll worry about that interior here in a little bit. Flip my direction. And I can snap to the region. So here's a time where I created the region not even thinking ahead, right? Just I think I might need that region later. But I could override that dimension, by the way, but just for the sake of the tutorial here. And if you ever need to change the classification of a region, click over to Properties and make this plain. Just a little tip there that'll get you. So we'll just move this down. Make sure that's a good section. You can silhouette it and do all those things. We're just going fast here. And then how I'd approach this is, again, I kind of rough in my bolt hole locations. Usually those are the things that it has to mate up with something else, right? So those are critical to get the right locations on. And then if I wanted to, I could do an offset to extract this location, right? But you'll notice that because this is a casting, and the exterior really isn't held to a very high tolerance there, that it is a little bit off. So you could choose to model them as is, to leave it just how it is, or try to make it a nice constant offset if you want. Or I can also do this and say auto sketch everything, make them all, and get rid of these ones that I don't want. So we're not going to worry about the inside right now. 6 of one, half a dozen of another. I'm just showing you this is another way that you can do it. Is it the best way, fastest way? Who knows? But I just wanted to show that that tool is there. And then for this one, we'll say extrude up to this plane, because I use that plane to align it. So that's why I'm saying extrude up to that plane. So there, if I turn on my mesh, turn on my surface, this is what we got so far. Now the first thing we need to do is extend these bad boys out and cap them. And depending on how it goes, we can, depending on how smooth my surface is, You can come over here and say I want to extend. Click these edges. Turn that solid back on. Make sure it's far enough. Yes. And then if you want to, now the reason why I didn't initially just say, hey, let's do both sides at once. If the surface has some wrinkles in it, sometimes extending them both in the same distance can be a pain. Just being honest there. But looks good to me, both sides. And then you can do a fill face. And if these planes are getting annoying, you just swipe them all off or turn them all off like that. And then once you cap this guy, you'll see it'll turn into a solid and disappear here. So now we have another solid. And before, let's do this real quick. Let's roll back. This is what's nice having history. Let's roll back one more. So I am going to offset the surface inwards, and I want to keep another option. You notice when I solidified it, it got rid of that surface. So a trick of copying this surface is if you go to transform body, there is this duplicate option, and you can hit OK and not move it. So you're transforming it 0. So now I have 2 of those surfaces. So if I roll to the end, now that the solid is there, and then I still have my surface. So just a little tip there. Now one thing I'm going to do is just come over here, turn on the mesh, do a mesh sketch. Turn off, turn off. I use shortcuts on my 3D mouse, by the way, for that, just to make it a little faster, because you're turning stuff on and off in here quite a bit. Now these aren't exactly lines, but I'm just using this as just a general idea to figure out what the thickness is here. There's a bunch of ways you can do this. So 0.055. Many times people will know this type of information, like what the wall thickness is there. And you could check it on both sides. Well, I didn't have any interior on this. So 055 is what it was there, actually. Oh, that's good. That's good. So that's why I was checking that, because that's how we're going to offset this guy inwards, right? So we're going to do a surface offset for this whole body. Just go ahead and click the entire thing. Inwards, flip the direction. So now I have my interior, right? So now I have my interior. Come back over to these ends. On this guy, let's do a mesh sketch. And you see here, it's essentially a circle. So I can do this. I can say, let's fit a circle there. But since I'm doing a loft, Sometimes it's better to do it with a spline. A little trick here, this is a SolidWorks trick as well. CAD softwares have this ability. This is a primitive circle, but if I want to fit a spline to it with a certain amount of nodes to it, I can. And you see here that it will create a spline for the circle. So when you're doing loss, that's just a general good practice, by the way. And the idea here is now I can say I want to do a loft from here. It's going to tell me, yeah, hold shift. And then you can move these guys around. This is another nice thing about using it as a spline. It's the fact that you can adjust these nodes a little better instead of doing it on curve segments, sketch line arc segments. And I'm going to say I want to do tangency to that face. So you'll see there that it flares out. Actually, I made a mistake by not doing. Uh, Actually, you know what I could have done? Let's do this. Turn off my solids. I could just do this, do a short little surface extrude. And instead of doing it as a curve to loft there, I could say, let's do a loft from this guy to that guy. Like so. Hey, let's try tangency on both sides and see. Interesting little guy there. So you see what I did, right? Same thing goes for this side. Make sure we select the right mesh sketch there. Turn everything off with my shortcuts. Now, you see this? I can draw it as line arcs. So this is the way I tend to do lofts, is draw it with line arcs first. So just, this is how I would do it, right? Rough the circle in first. Adds tangency automatically if you do that, right? So dimension everything. That doesn't look like it has tangency. So I would just fit here. Corner trim all this. And then power trim this. Yoy. That's because I didn't extend this. There we go. Add fillets if you want this to all like be dimensionable, right? But this is what I was talking about with that same tool here. The fitting of the convert to spline. I can basically fit with a certain tolerance a spline to this entire line arc sketch to make it easier to loft. Because if you've lofted things, if you're not lofting between something with the same segments, very difficult, right? So you can do something like that. If you've never done it before, you haven't felt the pain of trying to figure out what's wrong with your loft and get it to work right. So that's kind of why. If this bothers you, if it has the wrong normal, You can adjust the normal just by clicking like that. And then come over to surface loft. Right, so we're going to loft from there. Yep, I always do that. And then, of course, move these guys. And then, like we did before, and if you have nice, smooth surfaces, these tangencies will work. Like, um, if you don't have nice, smooth surfaces, sometimes it'll yell at you and say it can't do it. So if you see an error pop up, that's what it's coming from. Now we're going to go ahead and sew these. There we go. Sew them together. So now they're all one surface network. Turn on that solid. Do a cut. So you could cap them and then Boolean, but it's the same sort of scenario. Oh, forgot to do my other thing first. So let's go ahead and pause that. Let's Boolean these guys together first. Now it makes sense to cut from this. Hide the surface. And there we go. We have our little pipe here. And fillets. So you can try to use the edge fillet. This is going to happen, right? Where it's like whenever you do these boundary fit surfaces or curved network or like more elaborate surfaces, you'll run into fillets by using the edge where there's a problem. So this is where you would need to use a face fillet. And you say, I want to do a face fillet from this to these. These are a little more forgiving on the surface geometry, and you'll notice there we got a better fillet. Well, I always try the edge fillet first. Like, okay, no, didn't work. Now, again, it works on prismatic shapes. There we go. And you might have forgot, but there we have the little port guy. So the little port here, what I tend to do, and again, there's a bunch of different ways. I always learn stuff from people. People think more efficiently sometimes, but I will come in, create a region on this. Sometimes I'll create the region first. I don't know why it's taking a minute. Select my region, enlarge and shrink. And then shrink it back down to remove some of those little islands. And here's a neat little piece of functionality. If I come over and say, let's do a revolve, solid insert, pretty good. I'll edit here in a second. I'm just going to tell it to create that solid for me. And then we'll just come down, edit it, and remove the stuff we don't like. So I'm just going to come down and draw another line. Like that. And then this isn't what that is. I mean, I could have changed the sliders and stuff, but sometimes it's just easier just to come in and make the change on your own. And this could be a chamfer, this could be a fillet. You could add them in 3D if you want to. So if I want to add the chamfer and fillet in 3D, I can come in and say Let's fillet that. Oops. And then I could run the wizard here, and it'll tell me what it thinks it is. So if I say 04325, boom, hit OK, accept that. And then let's run a chamfer. Let's ask it to calculate for me. There we go. There are a lot of little ways that people do stuff like this, but what I tend to do is just, I'm a little lazy here, so I will come in and click on this. Flip. You could do this where we, yeah, actually that works perfect. Convert entities. Boom, done. Get out of that. Extrude down. And I'm just going to do extrude keep and then say, with that extrusion, Boolean, cut this guy from that. So we cut our hole. And remember, we still have that surface hanging out. So we can turn that on. Attempt to turn it on. There we go. And let's do that one. So we'll use this one, this tool entity, oops, to cut this guy. And then keep that. And turn all those off. Do a final Boolean. And just like before, fillets. Try the edge first. Probably not. So there's our little port. Same thing goes for this too. So there is our CAD model. Check your accuracy. Again, I made some decisions to smooth things and change things, so I'm not expecting this to be like perfectly green. If you're trying to make it perfectly green, yeah, you're going to use more entities that you're going to construct, and so I can adjust these fillets if I want to. Those are welds, so there is our model of this pipe. So that's just a tutorial on how I'd go about modeling something like this and all the tools that go into it. I hope this tutorial is helpful. Thank you for your time.